Well, hey there, everybody. It's your boy, Mr. Perry, and here we are back at it with Unit 1, Lesson 4. This time we are looking at expression and assignment. So let's go ahead and get into it. We're going to start with some quick little review here. In the previous lesson, we learned about variables. And here we have the definition of a variable, a name that is associated with an area of computer memory that stores a value necessary for a program to run. So a quick example would be string player name equals Hulk. We have over here, we are declaring the variable string player name. And then over here, we are initializing that variable with the value of Hulk. So what that means is that in our computer, we're going to take this value Hulk, and we're going to be storing it somewhere in our computer memory. And that is going to be associated with the name player name. Player name, again, will be the variable that is pointing to that area in memory, storing the value of Hulk. And we learned also about variable declaration, which is basically means we are identifying the data type and the name of a variable in order to reserve the appropriate amount of memory space. So if I say int secret num, again, what we're doing is we are reserving some Java memory. Maybe it's way over here. And secret num is the variable name that points to that area in memory. But of course, we haven't put anything in there. So right now, there's no value that's stored because all we've done is declared it. Similarly, if I say double my GPA and then have the semicolon, all that does is reserve an area of Java memory. And then again, my GPA is the variable name that is associated in it, and it points to this area in memory where eventually something's going to be stored. But of course, there's nothing stored yet because all we've done is declared the variable. Now, in today's lesson, we're going to get into assignment. Today's lesson is about expression and assignment. So what does it mean when we talk about assignment? Basically, this is initializing a variable. When we use an equal sign to provide an initial value to be stored in that memory, that's called a variable assignment. So if I say secret num equals 11, all right, now I've already declared secret num here. So if I now say secret num equals 11, I've now assigned the value of 11 in that area of Java memory. And these are, again, now associated with one another. And if I say my GPA equals 3.5, again, we are now storing the value 3.5 in that area of Java memory. So it turns out we can actually do things with variables once we've declared them. So right here we've got 4 lines of code, and we're going to look at something called incrementing, which is when we add to a variable. So this is very common in programming. You can see right here, int coins collected equals 0. So we're declaring the variable and assigning it its initial value of 0. And then we're printing it right here. We're going to be printing 0. So that, again, declares and initializes the variable and assigns 0 as the value. So the next line of code, we are printing it, so we would see the number 0. But then we get to this line down here that's in yellow. Coins collected equals coins collected plus 1. All right, so what's happening here? Over here, I'm identifying the variable that I want to update. I'm basically saying I don't want this to be 0 anymore. I want it to be more than 0. So the first thing I have to do is I have to identify the variable that I want to update. Then I use the equal sign. And then over here, it's what this means, coins collected plus 1. This means take its current value, which of course is 0, and then add 1 to it. So then down here where I'm printing coins collected again, this is now going to print the value of 1. So we are incrementing in this case. We've taken that initial value, we've added 1 to it. This is an example of what we call incrementing a variable. Okay, there are a few other things that we should know about variables, just kind of like some variations on the syntax that you might see. So you can actually declare multiple variables in a single line of code as long as those variables are all the same data type. So right here, it says int num1, comma num2, comma num3, semicolon. This single line of code declares 3 different variables. And then down here, of course, we're actually initializing them and giving them their value. and then down here we are printing them. We are concatenating these integers to these strings right here. And one of the nice things about Java is, unlike Python, where you have to put str in front of a number in order to concatenate it, you don't have to do that in Java. Java basically just knows already, okay, well, this is a string and I'm adding this. I just need to add this value to that string. So this would print the first number is 2, the next number is 5, the last number is 10 without any issue. It's also important to note that variables can only have one data type, but sometimes Java will convert the data type for you. So we're going to play a little game here. I'm going to ask you to pause the video. I want you to read these 2 lines of code, pause the video, and jot down what you think is going to print when this actually executes. So we've got string mynum equals, and then I've got the integer 5. So can I take an integer and store it as a string and then print it out? Again, pause the video, make a prediction. Let's go ahead and see what's going to happen. In this case, we get an error. Java will not let you store an integer as a string. Again, variables usually can only have one data type. So if you want to store a number as a string and then print it out, you would need to do something like this. String mynum equals, and then in quotation marks, 5. Remember, in Java, anything that's in between quotation marks is treated as what's called a string literal. And so this can be stored as a string. And then when you print this, it's going to go ahead and print the number 5 for you, no problem. So that's how you would deal with that situation. All right. Here we go, next round of the game. So again, pause the video, read through the code here, and make a prediction as to what you think is going to happen. We have int mynum equals 5.0. So this time I'm declaring a variable of the type integer, but I'm going to try to store a double inside of it and then print it. So again, what do you think is going to happen? Go ahead and pause and make a prediction. And let's go ahead and see what's going to happen. Once again, we're going to get an error code. It does not like to do this. Java will not let you declare an integer variable and then store a double in there. That again is just, it's going to get you an error message every time. Okay, last one here. What if we did double mynum is equal to 5 and then we try to print it? What do you think is going to happen if I declare a variable as a data type double, but then try to store an integer on the inside? Again, just let you pause the video, make a quick prediction. And let's go ahead and see what's going to happen. This time it works. It does print, and we don't get an error message, but it prints 5.0. So what happened is it took our integer and it converted it into a double, and it's now going to treat it as a double. So when you print it down here, it prints it as 5.0. So there's a reason for this. Doubles actually require more memory space than integers. So right here, when I declare the variable as a data type of a double, it reserves a lot of memory space. And so when I try to take an integer and assign that value to the variable that was declared as a double, integers require less memory space than doubles. So because this was declared as a double, we've got plenty of memory space to store this value of 5. But it does treat it as a double. So again, it's going to add that, it's going to make it 5.0. So Java will convert the int to be a double automatically. But remember, this does not happen in the reverse. You cannot declare an integer variable and ask it to store a double. And again, that's because doubles require a lot more memory space than what an integer has to offer. So you get an error message in that case. And this is, it's a minor thing, but it's going to be important for you guys to try to commit this one to memory. All right. So again, you can store an integer as a double. It will convert the integer to a double, but you cannot store a double as an integer. In that case, you get your error message. Okay. This lesson is also going to ask you to start using the operators, the arithmetic operators, or what I sometimes just call the math operators. Anytime you're working with ints and doubles, then you can use, obviously we're going to be doing some math. And even strings, you can use the plus sign to concatenate strings together. But of course you can't use any of the other math operators on strings. But when we're dealing with ints and doubles, when we're dealing with actual numerical values, the plus sign is used for adding, or what we call incrementing. The minus sign is used for subtraction, obviously, and that's also called decrementing. The asterisk or the star is used for multiplication, and then the forward slash is used for division. Okay, so let's go ahead and see what happens. What do you get when you try to add, subtract, multiply, or divide an int by another int in Java? So we're going to look at some quick math problems. Again, feel free to pause the video, write down your answers. You're going to find most of the answers are going to be correct in what you would expect, but you're also going to find that some of your answers are going to be a little bit different from what you would expect. So again, pause the video. Here we are doing different math operations with integers. And again, just write down what you think the answers are going to be. How is Java going to handle these calculations? And we'll go ahead and look at our answers. All right, so again, a lot of what you would expect happens. So 2 plus 2 equals 4, 10 minus 5 equals 5, 20 times 20 equals 400, 10 divided by 5 equals 2. But look what happens here. 11 divided by 2, it says it's 5. Now you might have written down 5.5 because that's the actual answer, but that's not how Java handles it. And then similarly, 9 divided by 2, Java says it's 4. Now you might have written down 4.5 because that's the correct answer, but that's not how Java handles it. So what we're looking at here is a potential problem. This is called truncating, and it frequently causes confusions for students when working in Java, and especially answering questions on the exam. This little tidbit of information right here can actually cost you several points on your AP exam. So this is an important thing to note. Basically what happens is in Java, anytime you're doing math, an integer, doing math with whether you're doing addition, subtraction, multiplication, or division with an int by another int, it's always going to give you an integer for the answer. So usually that's okay, but when you're expecting something that would be a decimal, what happens is it truncates it. So even though this is 5.5, Java just cuts everything off beyond the decimal point, and it just says the answer is 5. And even though this should be 4.5, again, Java just cuts the rest of it off and says the answer is 4. And that's because an integer divided by another integer is always going to give you an integer for the answer. So very important to take note of that. All right. What happens when you add, subtract, multiply, or divide an int by a double in Java? All right. So let's look at those same math problems. But let's go ahead and change one of the numbers to be a double, and let's leave the other one as integers, okay? So again, go ahead and pause the video, do the math, write out your answers, see if you get it correct. Let's go ahead and get into this and see what our answers are going to be. All right, so the easy answer here is anytime you do any math, that includes a double, the answer is always going to be a double. So if you add an int with a double, the answer will be treated as a double. If you subtract a double with an integer, the answer is going to be a double. If you multiply a double with an integer value, the answer is going to be a double. Same thing with division. So an integer divided by a double, the answer is going to be a double. And then notice down here, 11.0 divided by 2, now we're getting the answers that we were expecting, 5.5. 9 divided by 2.0 equals 4.5. So what you see right here, this is one way that you can solve the problem of truncating. so that you're not losing any data. If you know you've got a program that's going to be doing division, and if you know that there's a potential that the answer could be a decimal, then you need to make sure that, or one of the ways that you can do this is just to make sure that one of the numbers, whether it's the numerator or the denominator, as long as one of them is a double, you will get a double for an answer, and you won't lose or truncate any of that data. Okay, finally, what do you get when you add, subtract, multiply, or divide a double by another double in Java? You can probably guess the answer at this point, but if you feel like pausing the video and doing the math and writing out your answers, feel free to do so. I'm gonna go ahead and just do the reveal here. Let's look at what our answers are. Unsurprisingly, a double, do any math with another double, you're going to get a double as the answer. So 2.5 plus 2.0 is going to be 4.5. A double minus a double will give you a double. A double multiplied by a double is going to give you a double. And then again, a double divided by a double will give you a double. So that's good to know as well. All right, we're almost done here. Let's look at a few other things. What happens if we try to divide by 0? Dividing an integer or a double by 0. So here I've got int x equals 3 and int y equals 0. Down here I'm trying to print out x divided by y. What do you think's going to happen? Let's go ahead and check it out. We got a error message. It's an arithmetic exception is what it's called. And it's just basically saying you cannot divide by 0. So if you try to divide an integer by 0, you're going to get this arithmetic exception. What happens if we turn our numerator here into a double? So what if we try to divide a double by 0? What do you think is going to happen this time? Let's go ahead and find out. You don't get an error message, but you do get infinity. So again, dividing by 0 will result in these, kind of strange and unique responses. And there are a couple of other operators that you need to know in this class. So sometimes we use two equal signs. And this is what's called testing for equality. So basically, if I want to test whether or not a value is equal to another value, the way you do that in Java is you use two equal signs. So if I have two print statements, and if I want to print this expression, is 2 equal to 2, that's going to evaluate to true, and it's going to actually print true. And then if I have another print statement, and when I have this expression is 2 equal to 5, Java evaluates this to be false, and so it will print false. So two equal signs is basically what we use when we're trying to compare two values to see whether or not they equal to one another. We can also test for inequality using exclamation point and then the equal sign. So right here I'm basically asking, is 2 not equal to 2? Obviously that's false, so it would print false. Down here I'm asking, is 2 not equal to 5? Which of course is true. 2 is not equal to 5. So that would print true in that case. And then the last other operator that we need to know is the percent sign, which means modulo, or simply mod. And this is a very specific kind of math operator which returns only the remainder after dividing the first number by the second number. So again, play a little game here. What is the remainder when you divide the first number by the second number? Go ahead and do that for each of these. Write down your answer, and then let's see if you get the correct answer. All right? So again, pause the video and do your calculations here. See if you can figure out the remainders. And here we go. Let's go ahead and see what it is. All right. 10 mod 2. So what is the remainder when you take 10 and divide it by 2? Obviously, 2 goes into 10 5 times, and the remainder is 0. So 10 mod 2 is equal to 0. All right. What if I divide 12 by 5? All right, well, 5 goes into 12 2 times, and the remainder is 2. So 12 mod 5 is equal to 2. All right, now 15 mod 2. Okay, well, 2 goes into 15 7 times, and the remainder is 1. So 15 mod 2 is 1. Similarly, over here, we've got 12 mod 8. So 8 goes into 12 once, and the remainder is 4. So 12 mod 8 is 4. But this one here is a little strange. 3 mod 9. So 9 does not divide evenly into 3. So the remainder is just 3. And then finally 25 mod 3. All right, well, 3 goes into 25 8 times, and the remainder is 1. So there you go. This is how mod works, and it's an important one to know for this class. A couple of quick hacks related to mod. These are just really good rules to just memorize because you will see them frequently on your AP exam. Any even number modded by 2 is going to be 0. Any odd number modded by 2 is going to be 1. So if you have to check whether or not a number is even or odd, a really handy way of doing it is just to mod the number by 2 and see whether or not the answer is 0 or 1. A smaller number modded by a larger number is always equal to the smaller number. And we saw that with this one right here. A smaller number 3 modded by a larger number 9 is always going to be that smaller number. So that's just another easy one to keep in mind. And then another interesting one is any number modded by 10 will return what is in the ones column. So if you needed to isolate the ones column of any number, all you need to do is mod it by the number 10. So 25 mod 10 is equal to 5, of course, and that's the ones column right here. 337 mod 10 is equal to 7, and again, that's the ones column right here. So those are just some quick hacks, like I say, for mod, some rules that are useful to remember. Okay, lesson review. Data types play a central role in how Java handles data and how it evaluates expressions. So it's very important to pay attention to the data type for variables. Performing a math operation with an int and another int results in an int, even when the result from the division should be a decimal or a double. So we have that problem of truncation that we have to watch out for. Performing any math operation with a double will result in a double. There are several arithmetic or math operators to know and practice in Java. And with all of this stuff, just remember that the value of a variable can and will change during a program, oftentimes through the use of our arithmetic operators. All right, guys, as always, make sure you post a question or a comment or an observation about today's video content, and we will review that in class. As always, guys, thanks for watching. See you in class.